Hello, everyone. A very good morning to one and all present here. Dear authors and invited guests, welcome to Technical Session 6G. Myself, Richa Shah, and this session will be moderated by me. On behalf of the Global Knowledge Research Foundation, it is my great pleasure to welcome you to the ninth International Congress on Information and Communication Technology, ICICT 2024, London, UK. The ninth edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th of February 2024, and the virtual event is being held today through Zoom, that is the 21st and 22nd of February 2024. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 6 presentations, and each presenter will be given 12 minutes for the presentations and no minutes for the question and answer session. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you may write to me in the chat box. Just before we get started, I would like to introduce you to the session chair. So, our session chair is Dr. Amit Joshi. Now, I would like to start with the papers. I would like to call upon Mr. Michael S. Julius for the paper titled A Cloud-Based Medication Non-Adherence Assessment and Intervention System. So please could you start with your presentation?
Hello everyone, all the best for the presentations.
Hello, the moderator. It's like I'm having some technical issue here. I'll need some time, like 5 minutes to 10 minutes to resolve it now.
Okay, no
This,
problem. Then we can move on with the next presentation. You can present after them. Yeah? Does that
yes,
work?
thank you. It's
Okay.
okay.
So I'd like to call upon Mr. Thomas Gullis for the paper titled Creating a Self-Service DevOps Platform for Black Box Testing on Kubernetes. So please could you start with your presentation, please?
Hear me? Can you hear me?
Yeah.
Okay, thank you. Set this up. Okay. Can you see the presentation?
Yes, sir, it's visible.
Okay, great. So, hello everybody. First of all, let me introduce myself. I'm a student at Faculty of Informatics at STU University in Bratislava and a DevOps engineer at Slovenská sporiteľňa. And today I would like to present to you our article on self-service DevOps platform for black box testing on Kubernetes. And although this article covers two main topics, which are black box testing and self-service platforms, but the black box testing is pretty well-known concept, so I won't get into that much. The agenda for this presentation is divided into several sections: introduction, objective of the work, self-service, results, conclusion, and Q&A. So introduction. Pursuing optimal software quality is essential in ever-changing software development, which eventually leads to some sort of automation, whether it's automated builds, tests, or deployment, because it prevents errors and streamlines the whole process. And as the company expands, the number of application increases, the need for full deployment cycle automation. And of course, as more and more applications are being deployed to some kind of platform, the platform needs to be managed somehow and provisioned. For example, for a containerized application, there is a Kubernetes or OpenShift, and for if you are still deploying to VMs, there is something like VMware and Puppet or Ansible. But this article mainly focuses on the containerized application. So let's say you are a developer in a new team in your company, and you have several applications you want to deploy, and you want to manage your own cluster for some reason. There could be several reasons for to do that. But for that, you have to build your own cluster first, which is far from easy, especially in on-premise infrastructures. It is a pretty complex task, which requires a lot of knowledge about the platform, and also there is a provisioning of the platform. It's pretty complex. So how to make that easier? Well, self-service platforms. And even though cloud providers like AWS or Azure have some sort of self-service platforms, and that is true, but it still requires a lot of knowledge to build a production-ready cluster or production-ready environment where you can deploy your application and run them and provision them. So the objective of our work was basically we wanted to do is to build a self-service platform for black box post-deployment testing using GitOps principles with Argo CD to provision infrastructure and users cluster or teams cluster. The reason we wanted to focus on post-deployment testing is that it streamlines the whole deployment/testing process and makes it more flawless, therefore significantly decreasing the delivery time to production. Okay, so what are self-service platforms? Well, these platforms streamline infrastructure management and empower developers with more control and flexibility. And I know it sounds pretty generic, so let's break it down a bit. The way I imagine a well-built self-service platform is for the platform to be very simple to use. So the developer does not have to know all of the ins and outs of Kubernetes or OpenShift, and all he needs is, for example, to enter size, name, which environment he wants to cluster be in, for cluster to be in, and for example, which services he wants to have managed by the team that provisions or manages the self-service platform, and which services he wants to implement themselves. Almost every configuration should be overrideable by developer. For example, if they want to cluster default cluster in their company, but they want to implement, for example, their own service mesh, access control, and monitoring, they should be able to. Okay, the result, so far we've created a feature model where basically the user uploads a YAML file, and the application and the whole infrastructure, the whole system creates their desired infrastructure in cloud. As you can see, the system would basically work like this. User would upload their YAML file to the application. The application sends the information to through Terraform SDK to cloud provider. Cloud provider would create the infrastructure, and the application would return some CI/CD, some set of CI/CD pipelines with the build stages and test stages. And once the infrastructure is created, the let's say main Argo CD syncs the configuration from configuration repository to the Kubernetes cluster or some other cloud resources. And if the user pushes his CI/CD pipelines to his version control, GitLab or GitHub, for example, it creates a whole new pipeline. It starts the pipeline in a self-hosted runner, and after Kubernetes cluster is created, because it takes a while, it will create another instance of Argo CD for that team, which will provision their infrastructure and will be used to deploy the application. Once the application is deployed, the runner is constantly running and checking whether the application has been deployed, and after it is properly initialized and is running, it starts the post-deployment test. After that, the runner is will shut down. So basically, to sum up, self-service is great, but I feel like it's some sort of utopia. Red Hat is talking a lot about self-service and how they can provide it to their customers, but I feel like 99% of companies won't achieve this high level of automation, which is required for this self-service platform to run correctly. The infrastructure has to be almost anonymous. I mean, in Slovakia, there are still a lot of companies who are deploying manually, so I don't see this happening anytime soon. And if some company achieve this high level of automation, there is still one huge problem, which is that this platform heavily relies on the developer to actually want to manage their own cluster. I've never stumbled upon any team which would actually want to manage their own cluster. So that's it from my side. If you have any question, now is your chance. Okay, I will.
Any questions from the session, Chair?
Okay. There is no questions. That's it for me. Let me cancel the presentation.
No questions, I guess. So we can move on to the next presentation. Thank you for your presentation, sir. So now I'd like to call upon Mr. Vincent Hound for his paper titled on Next Vision, an intelligent video surveillance system based on computer vision and natural language processing. So you may please start with your presentation. Uh,
Okay, thank you. Can you hear me? Hello? Can you
yes, sir,
hear?
you're audible.
Yeah, let me share my screen. Okay.
Just a second, I'd like to introduce you to our other session chair, Professor Rachna Sable. She has also joined the meeting. She's also another session chair with Dr. Amit Joshi, sir.
Okay, good. Can you see my screen, please?
Yes, it's visible.
Okay, thank you. So hi everyone. I'm here to present first results about this research project that names Next Vision. This project was conducted with Prince Gédéon Guédié and me, Ratel Mondier. The main outline of my presentation will follow these steps. First, I will give you some presentation about the context and give some definition on the tools we use, and then we'll present our solution and the methodology used, and we'll finish with some discussion and conclusion about the work. So we know that today video surveillance is really important to enhance security, to reduce crime and full surveillance, and of course, to protect people. But with traditional video surveillance, you have um, some disadvantage and some challenge, I mean. And this work is going to deal with some problems that can be incurred with traditional video surveillance. Okay, good. So we present here four problems. That is, for example, the fact that the security guards who constantly monitor the screen can easily miss some important moment due to laziness, lack of vigilance, or human error, of course. And another problem is that we don't have the possibility to record some important moments. Okay. Um, and here the aim of this work is to tackle this kind of problem in order to record throughout some tests, some discussion with tools in order to uh, identify some important parts of a sequence of image or in a video. So the main problem is how to improve overall surveillance efficiency through interaction between system and operators to enhance security with AI. And mainly, we want to build an application, a system that is intelligent, flexible, and easy to use. The specific objective is to have a system that can analyze in real time or analyze a video and to identify some important parts. And these important parts can be described in tests to the application. So we use some important fields in AI that are computer vision, natural language processing. And I think that here we know that we know all these terms. In computer vision, we want to analyze images, in sequence of images or video. And in natural language processing, we would like to understand, to generate or to manipulate the language, the human language. So in this work, we use convolutional neural network to analyze the video. In particular, you use YOLO. YOLO, that is a pre-training model that help us to detect the different objects in the video and to track some objects also. And we use an LLM and a large language model. Mainly, we use the API of the GPT-3 to generate and to classify tests, to answer questions in a conversational manner, and to translate tests if needed. So you can see the main part of the architecture. So the main features of our solution are interaction for test-based queries. That is basically the GPT-3 API, support both recorded video and live stream, and we can question your video streams by detecting, counting, and triggering alerts for critical objects. So the main parts of our methodology are the following. First of all, we, of course, design the application, and we use the computer vision parts to analyze and detect the object from the queries of the users, and then we use, of course, the NLP part. So for the computer vision part, we identify several data sets and put them together to select, to learn how to identify critical objects. And then from this image, from this data set, we labeled these images according to a set of critical objects. And then we, of course, done some pre-processing pre-processing work on the image, mainly size adjustments. And then we we carried out the learning on the data sets. And for the NLP part, as I said, we use the API of GPT-3, and we detect some objects. We learn how to detect some objects like a person, of course, but our critical objects are mainly gun, knife, cigarettes, and and phone. And that's all. So for the tools used are mainly OpenCV, YOLO V8, Django for the application, Nest.js and Django, and OpenAI, of course, and LangChain to process the tests. On the data set, we can see some results on the critical objects, mainly gun, knife, cigarettes, phone, and you can see that the performance is pretty good. Here we have the normalized confusion matrix. You can see that on the gun, for example, we have 82% of well predicted values. Okay, I can see some images. At the left, we have the precision recall curves throughout the number of the epoch during the learning.
So just a gentle reminder that 10 minutes are over, so you'll have to wrap up the session.
Okay, good. I am at the end, and we can see some images. And you can see how to use the application. You can add your test and then detect the images. So to conclude, Next Vision combines computer vision and natural language processing to propose an interaction with video surveillance. The aim is to allow users to enter a description of that is critical for him or for her, and to have the sequence, the interesting sequence. So we plan to integrate a system of alerts, introduce some time-based event signaling, and that's all. Of course, we'll improve our performance by adding more data, by testing other large language models and add VQA model. So thank you for your kind attention. Yeah, I finished my presentation. Thank you.
Thank you, sir. Any questions from the session chair or anyone?
Yes, I have a question, sir. Actually, we saw your confusion matrix and precision recall curve also in the result part. Okay, but can you clarify about your model accuracy? I mean, you did not mention your model accuracy that you applied in your task. Please explain it.
Okay. Yeah, but the accuracy is around of the values here. So for gun, for example, we are about 80% of accuracy.
Not clear, please. I want actually you fine-tuned a model. Okay,
Yeah,
but how many accurate is your fine-tuned model? Can you clarify it, please?
are you somewhere here, or I don't get your point?
Your fine-tuned accuracy. I want just training accuracy and testing accuracy. Which model you fine-tuned? Okay.
Yeah, the YOLO V-WITS model.
Okay.
Okay.
Thank
Is that your question?
Okay, I got it. Thank you so much.
Okay, thank you very much.
Sir, I want to know. Hello.
Yeah.
Yeah. Sir, I just wanted to know, you were talking about the optimization of the model. So exactly what part you have optimized and what is the comparative of it as compared to the other models?
Yeah, since the data set, it is almost a new data set. So we test values, we have varied the different hyperparameters to find the best one. And the results that are presented here is the best results find.
So data set was created by you, or you have used the existing data set actually?
Yeah, we used existing data sets, but we call it is different data sets, and we put together different data set to have a bigger one.
Okay.
So thank you
Thank you.
for your question.
Any more questions from the session chair or anyone else? I don't think there are more questions. So we can move on to the next presentation. Thank you, sir. Thank you. So now I'd like to call Mr. Alex for his paper titled Real-Time AI and IoT-Based Systems for Home Monitoring. So you may please start with your presentation.
Hello everyone, can you hear me?
Yes, sir, you're audible.
Okay, let me show my screen. Can you see my screen?
Yes, sir, it's visible.
Hello everyone, I'm Adumadu Alex, a master student at the Africa Center of Excellence in Internet of Things under University of Rwanda. I'm here to present our paper called Real-Time AI and IoT-Based System for Home Monitoring. Annually, house burglary, theft, and assault increased year by year, and those home invasion have caused material and financial losses, confrontation that may even lead to death. This indicates that home businesses and individuals need to have a more security system to protect their home and the premises of the businesses. Having a secure home offers the residents serenity and security of themselves. Recently, advancement in IoT and IT had enabled safe and secure monitoring and control home and properties. IoT and AI enable remote house control, monitoring, and surveying. Therefore, having a system that has a smart decision improve human life. This project aims to create an autonomous system security that can detect and identify human in motion. Together with the AI model, the camera will help in differentiate between resident, family, relative, and intruders. The main objective of this research is to develop an IoT and AI-driven home security system with a focus on real-time monitoring and alerting. Specifically, we need to review the existing home security system for the weaknesses and limitations, design and develop an AI algorithm Internet of Things based system for home security using IoT devices, to train and implement an AI model that will help to differentiate between residents like family, cousin, visitor, as well as intruders, to test and compare the proposed system with other existing security systems. There are some researchers that have worked on this topic before, but the main limitation or gap that we have found that they don't have a clear alerting system or machine learning algorithm that can help differentiate exactly intruders from homeowner and then notify the homeowner. So the main gap that you have identified is that for most existing solutions, they don't have a big data set which can help to differentiate between authorized and unauthorized people. They only have one real-time alert. They don't have a comprehensive approach that incorporate the use and more sensor, especially IoT devices and AI algorithm. They don't have as well a dashboard for streaming, live streaming and backup data where you can visualize the data. The research contribution. This research mainly will contribute in home security consideration, whereby we will have a new security system for home that will help the homeowner to verify or to check who is there, to know which intruder at the what time come and the what time we go out, real-time alert and notification, real-time monitoring, and a comprehensive approach. The methodology of our research goes from the literature review to research design, up to the data collection, the model evaluation training, and testing the prototype. The system design and architecture is a combination of sensor IoT devices, central processing unit. Here you have three sensors that will be connected to a microcontroller that will have work of capturing any motion and then activate the camera in order to capture what is being done in real time, and then use an AI module to compare with existing data set and then make a difference between a homeowner and intruders. And at the same time, using a GSM module to alert the homeowner via a message as well as a buzzer to ring to alert them. And after being analyzed, the data will be sent to the cloud where you can visualize them using a dashboard. Data set. Our data set rely on personal image that were collected using the camera that we use for this project. And the data set consists of 10 different persons, where 40% of home members, 30% of extended family, and 30% of friends. The model training. The model training that you choose was a CNN, and it have two critical phases. The first phase was the data preparation, where you optimize, you normalize, and you augment the data set. Augmented data set means that it will help to have a robust data set where it can help to more prediction and clear prediction of edges. In our next phase, the second phase, the system model will learn from the data set and distinguish friend, relative, and extended family from intruders by recognizing the patterns that are associated with them. We optimize our CNN for precise detection of home member and intruder to careful adjustment of learning rate, both side dropout rate guarded against overfitting during critical model training and optimization phase. The experimental setup. Our prototype mainly consist of sensors, microcontrollers. We use two ASP and Raspberry Pi, as well as an AI module, especially deep learning, and we use an algorithm called CNN. The system cloud infrastructure facilitate further analysis, generating alert for emergency response and enabling real-time monitoring. Coming to the result and analysis, here you can see that our training accuracy increased as much as the epochs increased as well. And our training validation rate decreased as much as the epochs increases. At the beginning of our training model, you can see that the accuracy wasn't perfect. And then at the time at the input increased, the accuracy start to increase and it's become more constant when you have a high number of reports. Coming to the prototype result, where we have a dashboard that will help to visualize the data. Firstly, you have the home member where you have all the information about the home member. Secondly, you have the dashboard where you can see all the record of the recorded unrecognized person with the time and the date of recognition. Thirdly, you have the detected member family where you have the recognition time and recognition date of all the member family that have been recorded. And lastly, you have the live streaming, whereby when you receive a message about an intruder, you can open the live streaming and see what's being done in real time. We compare our solution with other existing solutions, and from this, we can see that most of solutions have real-time monitoring and are AI and IoT based, and also have real-time alert, but they don't have a dashboard for visualizing data as well as family member data set. Coming to the end of our presentation, this project achieved its goal of real-time AI and IoT-based security system. Therefore, this research showed that an IoT and AI system can easily help in identify and detecting intruder, so that it may help home premises to be more secure. The infrastructure constitutes of Raspberry Pi and IoT devices. The proposed AI algorithm that you use, CCNA, can be easily integrated with the cloud-based for processing, so that we can have a dashboard to visualize data later. The use of CNN result in an accuracy of 85% to 100 in detecting and distinguish human photo, demonstrating the system capability to maintain security. At the end, this study offers practical idea for enhancing home security and addressing security concerns. Thank you. If you have more questions, you're welcome.
Any question by the session chairs or anyone?
Sir, I wanted to know what is the dropout rate and learning rate that you have maintained in this algorithm for achieving the result?
See?
What is the dropout and learning rate that you have kept for getting the results?
Okay, you evaluate the dropout rate in terms of percentage. It's good from 85% to 89%.
And dropout is?
You say?
Dropout rate?
Dropout rate, I said you evaluate in terms of percentage from 85% to 89%. And the learning rate goes from 81% to 84%.
And what is the vanishing gradient issue, sir, you might have faced while using the CNN?
You say?
Vanishing gradient issue that CNN come across.
I don't get well your point. Can you be more specific?
Okay.
Can you be more specific, please?
Sir, I asked that CNN algorithm that you have used might be suffering from the vanishing gradient issue.
I don't get the point.
It's okay. It's okay. It's okay. Thank you.
Okay. So any more questions, or should we move on to the next participant? I think no more questions, so let's move on to the next participant. So we can move on to the next presenter. So Sir will be presenting on his paper titled VCIVS, Integrating Voice Cloning Technology to Improve Vietnamese Storytelling. So you may please start your presentation.
So, hello, can you hear me?
Yes, you're audible.
Okay, share my set screen. Okay, can you see my screen?
Yes, it's visible.
Okay. Hello everyone. My name is Thanh Lâm Bùi, and I'm here to present my interactive voice cloning technology for improved Vietnamese storytelling. And the first, my presentation following my step, this introduction and related words, our proposal system, and for this conclusion. So the first is introduction. So in today, the fast-paced world, the traditional of storytelling to the children is due to time's constraints. However, the growing recognition of its crucial role in language development and cultural connection is driving the development of voice cloning technology to personalize storytelling experience. So thereby opening up numerous potential applications beyond resembling the storytelling tradition. So in the related works, certainly when diving into the related works, it's essential to explore existing research and initiative that highlight the significance of storytelling in the child development and the challenge in face in contemporary society. So additionally, examining advancement in the technology, particularly in voice cloning and how they have been applied in the various fields, can provide valuable insight into the potential of the leveraging such technology for personalized storytelling experience. So by understanding the current landscape of the both traditional storytelling practice and technological innovation, we can better identify, unfortunately, and strategies for integrating voice cloning into the story to address the challenge of the time constraint while preserving its cultural and developmental benefits. So the first in the related was is the voice cloning. So it have three main methods. We found a diffusion by methods. So we have observers that they operate by model the audio signal diffusion process to capture subtle detail of the speaker voice. However, they fall challenge in terms of computational complexity and require substantial amount of data for training. So the next is codex-based methods. The codex-based methods is focused on encoding the voice signal using compression algorithm, and while fans solely in the computational requirements, they often compromise on the quality and naturalness of the generated voice. So the last is voice encoding methods deliver a speaker verification task levels advancement in the speaker verification technology to create a voice that's more familiar and natural. So the next, furthermore, several storytelling products have been developed, such as Tidy Story, Speechify, CoMO, and Gitpost. So I have a table to the comparison between storytelling product. So I talk about this statement emphasize the company commitment to provide personalized experience for a user by converting their voice into the storytelling narration and tailor content for a user in Vietnam. And upon analyzing existing products, it observes that only CoMO meet the requirement for personalization. ABUS with maximum time limit is 50 minutes. And in contrast, while the keyboard and Speechify support Vietnamese language, they lack robust personalization feature compared to CoMO. Therefore, this is a proposal to develop a new product to combine both aspects supporting Vietnamese language, providing higher level for the personalization, along with the implement of a new system to achieve this goal. So talk about my proposal system. So The process involves gathering is have two main, the web storytelling system and voice cloning service. So the process involves gathering both of the voice recording and story on the web system. They send in the trend request down to the voice cloning service. So this voice cloning system will synthesize the story with the recorded voice and return them to the web interface for the users. So the first is the voice cloning service. So this target speak through fast into the speaker encoder and converts to the embedding vector. At the same time, the text will be fast through in the synthesizer. After that, the synthesizer will convert this to the male spectrogram to the vocoder, and the vocoder trains the male spectrogram to the waveform. So talk about the first component is the speaker encoder. So it so speaker encoder, the task of this session to generate distinct feature vector for the voice that needs to be cloned. So based on the experimental result from the paper, its event of the ResNet model generally exhibits lower error rate compared to other models such as TDNN and ICICT TDNS, which were exchanged and tested on the Vox-Celeb dataset. So, but to meet the requirement of the task necessitating high-end hardware, this study emphasized the retrained ResNet 34 model design with speaker verification, a speaker encoder. So the next is the vocoder. Okay, this component is designed to convert male spectrum feature into the spoken audio waveform. Several models has been proposed as three essential in this task, such as WaveNet, WaveGlow, MailGain, and HiFiGain. So based on the research in the table, we use HiFiGain for decoding frameworks in microchip. So the next is synthesizer. So in the synthesizer, we use two models. This is multi-speaker FastSpeech2 and your TTS with a rich dataset of Vietnam. So about the computational infrastructure, we training with GPU A100 with a back size of 16 and nearly 1 million iteration. So about this dataset, we use three datasets in here. The first, this VVOS dataset from ALAB. This is the public dataset in 2016 and includes voice recording over 50 native Vietnamese volunteers. So the second is the VinBit dataset. So this is designed for the task one of the VLSP 2020 International Workshop and comprise 100 hours of recording, includes studio recorded speak and reform speak collected from the open source. So final, this is a self-collected dataset. So it includes approximately 100 hours of recording obtained through the VCTube tool. So to evaluate two models, we use two metrics in there. Okay, this is DNS MOS and G2E. So in DNS MOS, we use to evaluate the quality process audio signal with score rating from 1 to 5, corresponding to 4 to excellent quality. And G2E used to assess the similarity between feature vector of speaker. So you can see in the table, of the multi-speaker FastSpeech2 have 4.3 DNS MOS and
So 10 minutes are over. Just a gentle reminder, you'll have to wrap up.
okay. So with this point, we chose multi-speaker FastSpeech2 for my project, and we using design my project with three distinct after admin, parent, and guest. So we using merge stack for storytelling system, and this is some of feature for we website. And this preserve of the user with for criteria clarity of voice, emotional connection, comprehension, overall user satisfaction. And so in conclusion, we successful experiment with multi-speaker fast speech tool and your TTS for Vietnamese storytelling, and select of multi-span speech tool for supervisor voice quality and emotional vision. Development of comprehensive Vietnamese voice clone service integrating synthesizer, vocoder, speaker, encoder, and component. So thank you for your listening. Okay, my recent paper on the end.
Any questions from the session chair or anyone?
So can you please tell me what are the various features of the dataset that you have considered?
About the database.
Yeah.
So we use 3 database in this. Okay, this 3 database. We have 3 database. So
what type of features do the database contains that we have used for training the model? For training the model, we use various features of the database, na? So what are the main features that you have considered, like for training the model?
Sorry.
Okay. And what are the various metrics, sir, apart from the 2 that you have used? What other metrics can be used?
These 2 metrics in this DSS MOS.
Yeah. Yes. Apart from this, are there various evaluation metrics apart from these 2 that we can use for showing the comparison?
We decision of multi-speaker fast speech tool for the storytelling. So this is more authentic and emotionally enriching storytelling experience.
Okay. Thank
you.
So now we can move on to the next presentation. Thank you for your presentation, sir. Mr. Julius, are you ready for your presentation?
Yes. Can you hear me?
So you may please start with the presentation.
Okay. Okay. Can you see my slide?
Yes, sir, it's visible.
Okay, thank you very much. I sincerely apologize for the technical issues. Thank you very much for your patience. My name is Mr. Julius, and currently I'm running a program on data science in ICICT Federal University here in Nigeria. But I'm presenting part of a large project called Intelligent Medical Adherence Intervention System. But this particular paper captured the cloud-based medication adherence assessments and intervention system. The motivation has to do with there is need to have a healthy citizens that makes up a healthy nation. And so as the population of our people grows, we have a lot of issues with chronic illness among their patients. So we looked at the prescribed medications, medication adherence that leads to clinical success to make up healthy citizens and nations. In this presentation, we will be looking at adherence to prescribed medication is the only antidote to effective and efficient patient health management, especially outpatient with chronic illness. Medication not taken cannot work. The scenarios we have asthma patients, asthma outpatients, we have diabetic, hypertensive patients that needs a long-time management for them to be healthy. The highlights of the presentation will look at the introduction, medication non-adherence concepts, statements of the problem, aims and objectives, selected key and related studies on methodologies, information gathering method, system development methodology, and system design. Finally, we look at implementation and conclusion based on the result, discussion, and the future work. Now, the introduction. According to the World Health Organization, we see that patient non-adherence to medication is a global problem in the public health delivery. And we see for this to be solved, technology has coming. So we look at as globally acknowledged technology is the indispensable wheel upon which public health care service delivery system must ride on in order to achieve their core functions and meet the diversity demand of all stakeholders. Now, the statement of the problem. Advances in pharmacology and therapeutical would have yielded better impact and results in effective management of patient illness and disease, especially the chronic one, if patients would adhere to their prescribed medication. However, patient non-adherence to medication is highly prevalent, and it has continued to be a serious challenge in healthcare service delivery with multidimensional consequences. Of course, we can talk about how it prolongs treatment duration, how it diminishes treatment effectiveness, how it lowers life quality, wastes healthcare resources, increasing healthcare costs, even sometimes causes health complications that leads to death. The challenge of ineffective and inefficient adherence intervention due to alert fatigue. This is because there are several technological-driven interventions to improve medication adherence. However, this advancement in intervention has generated a new set or a new domain of challenge, which is message fatigue, override, and message irrelevance. And for institution to develop a software, individual healthcare facility to develop a software is highly expensive, and there is need to have a cloud base. And that takes us to the aim. The major aim is to develop a cloud-based medication adherence assessment and intervention system that aim to improve the medication and non-adherence. Specific design, our objective rather, will have a user-friendly cloud-based system for assessment of patient level of medication non-adherence and associated factors that influence non-adherence among individual patients. Number two would be to develop and integrate SMS, agent voice call, and USSD API via Twilio and Africa token. This is to deliver a personalized persuasive adherence intervention. Then finally is to evaluate the proposed method with ISO 1970 standard. Now, for the literature review, there are quite a lot of research that have been carried out due to non-adherence is a long age problem. What has been done and the research gap and what to be done. Let's look at what has been done. In this view, we see assessment of patient knowledge, belief, and perception using Morisky adherence scale. This has been proved to be very effective to ascertain the factors that influence medication non-adherence among patients, especially outpatients with chronic diseases. I will also see the GELI 2019. It's evaluate the factors as well and made mention of the patient knowledge, belief, and
Yes, you're audible.
okay. Yes, what has been done so far is actually based on the evaluation and assessments of medication non-adherence and the factors that influence medication non-adherence. And the research gap is being summarized in two forms. One is this assessment of medication non-adherence and intervention to improve medication adherence. Now, for the assessments of medication non-adherence and its factors, a long list of assessment questions for each identified factor is usually being used, and that board patients to respond to that. And in case of, in terms of intervention, there are a lot of message fatigue due to massive sending and receiving of alert messages with regards to medication and treatment. And then lastly, several studies on adherence intervention fail to take into consideration the patient medication adherence assessment before the design and deployment of adherence intervention strategies. All this has been addressed by the new system. The methodology is a threefold methodology method involved. One is the mixed research method for data gathering. Two is the analysis and design for the system. And lastly is the development of the new system. We've seen that the conceptual network, the framework of the system, of the proposed system, based on the cloud, it has a cloud computing. Then it has the users. These are different patients and healthcare workers in various registered healthcare facilities. Then we have the medication adherence assessment and intervention application. Then the multi-tenant database. All these are the components of the proposed system. There's a system architecture. We see that the users are classified into two. We have the mobile phone user and we have the web-based user. We also have the mobile phone user and the desktop users are grouped into one. Then we have the major application, which is adherence assessments and intervention system. It is actually developed on three-tier architecture, which is the client, server, and application with database. A use case diagram is used to explain the various users in the system and their corresponding interrelationship. Now, the results, the result is looked into, is divided into three. One is the assessment of patient medication adherence level and other factors that influence it. Two is intervention to improve medication adherence. And lastly is the system and data security with regards to the implementation. The assessment of medication adherence level of patients using Morisky adherence scale, which is generally accepted. It has 8 items of assessment. As you can see, we have those 8 items, and the patient is being presented with these 8 items of adherence questions. And once the patient responds correctly to this survey, the system will generate and calculate the cumulative score of each patient to determine the adherence level of that patient. And not only the adherence level, the factors that influence adherence level, which are the belief, the knowledge, the perception, and the belief, knowledge, the perception, and the of the student of the patient. We see the result here: assessment of adherence level being 2.0, and the result is low non-adherence. And if it is 11, we see highly forgetful. That's for the assessment. For the assessment result classification, the system classify all the assessments, including medication non-adherence and the perception, patient perception towards medication and medical advice, patient behavioral pattern, and patient belief on medication, and patient knowledge on medication and diseases. The system analyze the responses from the patient and interprets the responses based on cumulative score. If you the cumulative score for patient medication non-adherence means that if the cumulative score is falls between 0 and 1, it means that the patient is very low non-adherent. And if it falls between 2 to 3, it means that the patient has low non-adherent. And if it falls between 4 to 5, it means the patient is highly non-adherent, and if they fall between the cumulative score of 6 and 8, it means that the patient is very highly non-adherent. The system uses this algorithm to generate the assessment result classification. The same thing is applicable to patient perception towards medication and the medical advices. If the score falls between 0 to 3, it means that the patient has a bad perception. And if the score falls within 4 to 6, it means he has a fair perception. And it falls within 7 to 9, it means that the patient has good perception. It is fall between 10 to 12, it means the patient has excellent perception. The significance of this classification is to aid the appropriate intervention to be deployed to meet the patient need with regards to medication non-adherence. The delivery tools rather for the intervention to improve medication adherence, there are three that these systems utilized. One is the uh, agent voice call. The second is the personalized SMS, while the last is the USSD. So with these three tools, our patient can be delivered a personalized and persuasive message that can improve their medication. In conclusion, cloud-based medication non-adherence assessment and intervention has been developed to improve patient adherence to medication. The system provides a secure patient-centric intervention tailored towards individual needs by first of all knowing the level of medication non-adherence of the patient and determines whether or not the patient need adherence intervention and the type of intervention strategies to be developed and delivered to the patient. Thank you for listening.
Any questions from the session, Chair?
Sir, you have talked about the security features also. So can you just elaborate what kind of security has been embedded?
Yes, there are three layers of security embedded in the application. One, during the design stage, the database, the data entering the database have been encrypted. And the second, during the deployment stage in the cloud, the separate scheme type is being adopted, meaning that each registered healthcare institutions has their separate database, and in that there is a high level of security. And lastly, in the hosting package, even the WHO's privacy is also deployed to make sure that the security is guaranteed with the secure sockets layer put on the domain name.
Okay, thank you.
Thank you, sir. So now,
Thank you.
I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during the ninth version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2025. All the presenters would be given their digital certificates via mail within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2024. I also like to thank our session chair, Ms. Rachna Sable, for chairing this session. This is a token of appreciation to the chair on behalf of Team ICICT 2024 and Global Knowledge Research Foundation and partners. Thank you, ma'am, for your valuable presence.
Thank you, Richa,
Now
and thank
we'll-
yeah,
Yes, ma'am. Thank you.
yeah.
Now we'd like to end the session, but before that, I request you all to switch on your cameras for a quick snapshot. Can everyone please switch on the cameras? Okay. Thank you, everyone. Have a good day.